Hello, welcome to ATI 4640. In the last session, we started addressing process analysis and design tools. Some of the discussed tools were flowcharts, time function mapping, and process chart. In this session, we will continue addressing process strategies and the different tools and techniques that will be used to analyze and improve processes. Another tool that can be used to analyze and design processes is the value stream mapping tool. This tool starts with the customer and extend all the way back to the supplier. And what we do, we are going to map production processes and identify value added and non-value added activities from the customer all the way to the supplier. To use value stream mapping analysis, you need to create symbols for customers, suppliers, and production to ensure that big picture of the supply chain is depicted. Then we enter customer order requirements and calculate the daily production requirements. The following step will be to enter the outbound shipping requirements and delivery frequency. Then we determine inbound shipping method and delivery frequency. Then we identify and add the processes that the product will go through until it gets packaged and shipped to customer. We add to the mapping the communication methods and their frequency, showing the direction of communications using arrows. We have direction of communication from the customer all the way to the supplier of supplier, and we have communication from supplier to manufacturer to customer. Of course, when you place the order as a customer, it will go in the direction of the manufacturing and the supplier. When the supplier send the material to the manufacturer, they send the invoice, and when the manufacturer build that product and send it to the customer, they send the invoice to the customer, and so on. So we have communication going back and forth between the customer, the supplier, and the manufacturer at the same time. Then we add inventory quantities before or between every step of the entire flow. Now remember, whatever the supplier ships to the manufacturer, most likely they will have at least a small inventory to do it for the production, or to save that inventory for the production. Once it's produced, it will be the finished product will be also in an inventory until it's being shipped to the customer. And it's the other way, if the customer would like to return something, then they have to return it to the manufacturer, who will return it in turn to the supplier. So we have the movement of items going back and forth. Also, the material will be going back and forth in the supply chain. And in the last step, we determine total working time, the value added time, and delays, the non-value added times. Most of the time we have lots of delays in the system, and that's what makes it a non-value added activity. This figure shows the value stream mapping of a GPS production company. This is a company that produces GPS systems, and from the mapping you can see that non-value added activities represented by delays or waiting are 26 days. You can see here 5 days until it gets to the machine, 3 days until it gets to the component mounting, and 6 days until it gets to the assembly, and then another 4 days to testing, and 4 days to packaging. So basically all that time was waiting, while the processing was 45 seconds, 40 seconds, 15 seconds, 20 seconds, and 20 seconds. So the non-value added activities were 26 days, while the value added time per unit was 140 seconds only. To identify the process of customer interaction with service provider, we develop a blueprint. So for the service, it's different. For manufacturing, yes, we can draw the flowchart that shows the supplier, the customer, and the manufacturer. What about service? For the service, we do what we call, or we develop what we call a blueprint. The blueprint defines three levels of interactions with the customer. Each level has different management issues. Using the blueprint, we can identify potential failures points and improve those failures or eliminate them if possible. So this figure in this slide shows a general blueprint for a service starting from customer arrival all the way to customer departure. The blueprint shows potential failure points, and that's indicated with the letter F or marked with the letter F, where we need to monitor employee behavior to ensure successful process. For example, greeting the customer at arrival, failing to do that may drive customer away. Training employee on the proper response will improve the process of greeting. So that's the failure here in this part. So again, we have to follow the different processes that we are providing for the customer and different interactions and identify the failure points and try to minimize it. You can include instructions or guidelines or checklist as foolproof or Pokayoke points of addressing the failure or points to adjust those failures to reduce or eliminate those failing points. Some interactions with customer is necessary, but this often affects performance adversely. The better these interactions are accommodated in the process design, the more efficient and effective the process is. We need to find the right combination of cost and customer interaction to make sure that we are not compromising the interaction with the customer just for cost. If we draw the relation between degree of labor versus degree of customization, we will get the following figure that identifies in which quarter some of the services are. And we can look at our service and see where does our service fit. When you suggest a service or you create a new service, you can look at do you need a high degree of customization or low degree of customization? Do you need high degree of labor or low degree of labor? And based on that, you can place yourself in the proper quarter, and that will give you an information on what need to be done as a strategy for that level that you are in. For example, hospitals that has high degree of interaction with customers, with the patient, through customizing the service based on customer sickness or injury, with low labor where one nurse and one physician can take care of more than one patient. From the matrix, we can find that mass service and professional service involves high labor. Selection and training are highly important, and focus on human resources and personalized service. So that's for the mass service and professional service up here. We can also find that service factory and service shop will be characterized by automation of standardized services, low labor intensity, response well to process technology and scheduling, and tight control required to maintain standards. To improve service productivity, there are some strategies that can be utilized, such as separation, where the service is structured in a way that the customer must go to a specialized person to get that service. For example, bank customers go to an account manager to open a new account, to loan officer for loans, and to a teller for deposits. So that's the separation between the different services that's being provided by the bank. We can improve service by promoting self-checkout. In most supermarkets now, Walmart, Winn-Dixie, and other supermarkets, Home Depot, Lowe's, they are doing or adding the self-checkout process. We can also improve service productivity through postponement such as customizing vans at delivery, or by focus restricting offerings or limiting your business to offer certain service like in and out, which is a restaurant in California which offers only beef burgers with fries, no chicken, no fish, no ham, nothing, just uh, burgers, the beef burgers, and you will have two choices, either cheeseburger or regular burger and nothing else. So that's one type of a sandwich, or one or the menu short, and that can provide for you a focus on the product that you are dealing with. It could be also by modules, for example, insurance selection. So it's not only the manufacturing environment where you see modules. You can see that also in services. And it shows that when you go to um, the different insurance companies, and you start selecting different checkbox or different packages, and then at the end you will have, with these different modules, you will have a package, the final package, that will be your insurance. In addition, if you go to now AT&T, Xfinity, or any of these companies, you can select to add the services of wireless TV. You can select to add the internet package. So those are modules that you can select and add and create the service that you want. We can also add automation in service, like the ATM machines in the bank. We can also automate scheduling, like scheduling the ticket counter personnel at airlines. We can do it now through online or through the counter personnel, maybe in 15 minutes intervals. And last, by training employees to clarify the service options and explaining how to avoid problems, such as training reception employees in a hotel to greet and provide customer with different options available and avoid problems with customers. One of the factors that affect processes and might play a great role in process improvement is equipment and technology. Sometimes it's hard decision to take and to select the proper technology, but that might provide the organization with competitive advantage. You would like to select the proper technology for your company so you can actually compete in the market. So through adding flexibility and stabilizing processes, you can add this competitive advantage. Technology may allow enlarging the scope of the process, such as websites that allows online ordering instead of the limitation of in-store orders only. Some of the production technology that we can use or can be listed is machinery technology, the automatic identification system, process control, vision system, the robots that's been spreading all over the place now, even in service, automated storage and retrieval system, flexible manufacturing systems, and computer integrated manufacturing. The use of machine technology increased precision, productivity, and flexibility. It reduces environmental impact. It supports innovative product design, minimal custom tooling required, minimal assembly time, low inventory, and reduced time to market. Some of the well-known used machine technologies are computer numerical control, or CNC machining, and additive manufacturing, which is adding material layer by layer like 3D printing. The automatic identification systems and the use of radio frequency IDs improved data acquisition and reduced data entry errors. Since all items can be scanned electronically by the system, that increased the speed of item tracking and the ability to improve many processes. The process control, which is real-time monitoring and control of processes increased. Actually, this uh, real-time or process control increased the process stability. It actually increased process precision, gave real-time provision of information for process evaluation, and made data available in many forms. Vision systems, the different systems that we use for vision aids a lot in inspection, and it's consistently accurate. Now remember that we used to have people on the manufacturing line or in the production line looking at some of the items that are defected and removing the defected parts and keeping the accurate parts. But if we have if we can install cameras that will do the inspection for us with more consistency and more accuracy, and it will not it doesn't need rest, never bored. And now with the cameras that we have and technology that we have, the advancement, the cameras can be installed with modest cost. So these systems are superior to individuals and performing the same tasks with longer time. Robots perform monotonous or dangerous tasks. Robots can perform tasks requiring significant strength or endurance, such as the robots used in car assembly, which also provides consistency and accuracy, especially in welding, pressing, cutting, milling, and drilling. And like we said, robots now are being used in surgeries, so it can also be used in services if needed. Automated storage and retrieval system, which is used in the warehouse system or distribution system. It automates placement and withdrawal of parts and products which reduces errors and labor. This system is mostly used in the inventory control system and in manufacturing firms. As you can see, those systems can go to a higher level than the regular forklift or the regular working employee using a ladder, which will be also dangerous. So we are reducing the risk, we are automating that, and we can store on higher level or utilize the whole warehouse space. The automated guided vehicles, which is electronically guided and controlled carts used for movement of products and or individuals, and that's another technology that plays a huge factor in improving processes and increasing efficiency. And part of the automated guided vehicles are the forklift. So we can use the forklift. We are not forgetting about using forklift in the process, but also at the same time we can use the automatic retrieval system if needed, and if we need to utilize the whole space for the warehouse. In flexible manufacturing systems, computer controls both the workstation and the material handling equipment. So the FMS can enhance flexibility and reduce waste. It can economically produce low volume at high quality. It can reduce changeover time and increase utilization. It has strict communication requirements between the different components. The computer integrated manufacturing, which is an extension of flexible manufacturing systems, it extended process improvement all the way back to the engineering process, the design, and inventory control. It also went forward all the way to warehousing and shipping. It can also include financial and customer services. So we can automate everything, use the computer to assist me in basically automating all these processes and controlling all these processes. We can do the invoicing now electronically. We can do the orders electronically. We can do inventory control electronically. The design, we can use the computer to create CAD design and other designs. So basically, the computer integrated manufacturing or integrating computers in manufacturing is a huge thing, and it assisted me in many aspects and reduced lots of the time and the cost that was before. Uh, and again, we said it can include financial and customer services. That means that we can even pay the transaction. All the transaction can be through now online means, and everything automated. It doesn't have to be in person. So the computer integrated manufacturing reduced the distinction between low level, high level variety and the high volume and low variety production through the ability to change configuration using dashboards and touch screens. We can use the configuration for the different machines, and then we can change the variety of the products that we are producing and change the volume from low volume to high volume, so that even that difference been reduced, and it can be easy, or we can do it easily. This figure shows the integration of different computer-aided systems together that works together in the manufacturing environment. And again, we can do that in the service industry too. This table provides some examples on technologies used in service industries such as financial services, education, utilities, and government, restaurants and foods, communications. In all areas, we can still use technology, and we can use computers. So in financial services such as electronic fund transfer, or in education such as electronic built-in boards and web courses, or the learning systems online, in utilities and governments such as the flood warning system, in restaurants such as wireless order from waiters to kitchen, and now even you can pay. They will bring you at your table, they'll bring you a machine where you can pay it at the table, and you don't have to give your card to the waitress to make a payment. And for communication such as the interactive TV and other services that's been provided. More and more examples can be found in different areas of service, where wherever you go, wherever you look, you will find some kind of technology that has been utilized to improve service and provide consistency and accuracy, including healthcare and airlines. One of the options that we have to improve a process is to redesign the whole process. So if we look at these processes, analyze them, and we found a problem, one of the options is to redesign the whole process from the beginning. The redesign is the fundamental rethinking of business processes to bring about a dramatic improvement to performance or to efficiency. It relies on revealing or re-evaluating the purpose of the process and questioning both the purpose and the underlying assumptions. It requires re-examination of the basic process and its objectives. It focuses on activities that cross function lines. We have cross-functional lines. That means it can be in many departments at the same time, or multiple departments. So that's why we call it cross-functional. But the question is, which processes need to be redesigned? And actually, any process is a candidate, because always there will be an opportunity for improvement. So even if we improve a process now, in maybe few months, few years, it might need another improvement. So always we keep on looking for improvement. We keep analyzing processes. We keep designing and redesigning our processes to make sure that they are achieving the goal and they are meeting customer expectations. That will be all for the session. If you have any questions, please feel free to email, Skype, call, or come in person. Thank you and have a great day.